So here we have to explain the concept of how to find the area enclosed by two curves with some examples. So the rule is that suppose if we have some function f of x, suppose this is the graph of the function y equals to f of x, and suppose we have another graph of the function y equals to g of x. So let's say this is the x-axis and this is the y-axis, and suppose they intersect at some point a and at some point b, and the x coordinates of those points are, suppose x equals to a and x equals to b. So they will intersect on the straight line x equals to a and on the straight line x equal to b. So we need to find the area of this region. Suppose we need to find the area of this region which is enclosed by these two curves. So therefore the required area of this region, of the shaded region, will be equal to uh, integral of f of g of x, integral of g of x minus f of x into dx, and it will go, x is going from a to b. So why we wrote this g of x minus f of x? Since g of x is greater than or equal to f of x for all values of x uh, belongs to a to b. So for all values of x from a to b, the function g of x is greater than f of x. So we should write g of x minus f of x integral dx. So actually the area should be equal to a to b mod of this f of x minus g of x into dx. So now since g of x is greater than or equal to f of x, so I can tell that g of x minus f of x will be greater than or equal to 0. So it means that mod of f of x minus g of x, that can be written as g of x minus f of x. Since why? For all values of x going from a to b in this interval from a to b, the function g of x is more than f of x. So you should write the area in this form. So now in the second case, suppose we have the function f of x like this, and if we have g of x, suppose like this, suppose this is the graph of f of x, this is the graph of g of x, means it is y equals to f of x and this is y equals to g of x. So this is suppose the x-axis and this is the y-axis. Then suppose this point, so these two curves are suppose intersecting at 3 points a, b and c, a, b and c. So then suppose they intersect on the straight line x equals to a, and they intersect on the straight line x equals to a, x equals to c, and they will also intersect on the straight line x equals to b, suppose. So here we need to find suppose the area of this region and the area of this region. So now here in this region, we can say here in this region f of x, here f of x, the function f of x is more than g of x. So here f of x is greater than or equal to g of x. And in this region, g of x is greater than or equal to f of x. So we can say that in the interval from x going from a to b, a to c, f of x is greater than or equal to g of x. And in the interval x going from c to b, we can say that g of x is greater than or equal to f of x. So the required area of the shaded region, that will be equal to integral f of x minus g of x, and that will dx, and that will go from a to c. since in A to C f of x is greater than g of x, and plus it will be C to B, then I should write g of x minus f of x integral dx. So this concept we can understand by using some examples. Like suppose we take one example. Suppose here we are asked, suppose find the area of the given shaded region. Find the area of the given shaded region of the given shaded region which is lying above the x-axis, and between included between the parabola included between the parabola and the circle from the y-axis which is x equal to 0 to x equals to suppose 8a, x equals to 8a. So here suppose the equation of the where the equation of the parabola is given as y square equal to 4ax, and the circle is given as x square plus y square equal to 8ax. So it means that the circle will pass through the origin, obviously. So the circle will be somewhat like this. It will pass through the origin, which is 0, 0. And so if we simplify this equation of the circle, then we will get x square minus 8ax plus 16a square plus y square, that will be equal to 16a square. So this will be equal to x minus 4a whole square plus y square, that is equal to 4a whole square. So therefore the center is 4a comma 0 and the radius is 4a. Radius is 4a units. So it will intersect the x-axis at the point 0 comma 0 and at the point 8a comma 0. So therefore and the parabola will be somewhat like this. The equation of the parabola is y square equal to 4ax. So that will intersect at these points. And here we have to find the area of this shaded region, suppose this one, and with that this one also we need to find, suppose. So here this straight line is x equal to 8a and this straight line is x equal to 4a. So we need to also find at which points the parabola will intersect the circle. So we need to solve the equation of the parabola with the equation of the circle. Then we will get x square plus 4ax equals to 8ax. Then we will get x square equal to 4ax. So then we can write x into x minus 4a, that will be equal to 0. So x will be equal to 0 comma 4a. So they will intersect at x equal to 0 and at x equal to 4a. X equal to 4a. Okay. So then from here we can so yeah, they will, so 0, so at x equal to 4a, y square will be equal to 4a into 4a. So then y will be equal to plus minus 4a. So it means that the circle will intersect the parabola at the point 4a comma 4a and at the point 4a comma minus 4a. Okay, so then sorry, yeah, so then so therefore here the required area of the shaded region, the required area of the shaded region, that will be equal to the area of this region. We can say it is region 1 and this is region 2. So in the region, so area of region 1, area of the region 1 plus the area of the region 2. So in the region 1 we can see, here we can see in region 1, the circle is lying above the parabola. So therefore we can say the equation of this circle, we can say this is equal to y equal to plus minus square root of 16a square minus x minus 4a whole square. So then so it means the region of the circle which is above the x axis, this branch will have the equation y equal to square root of 16a square minus x minus 4a whole square. And that region which is below the x-axis, that will have the equation y equal to root over 16a square minus x minus 4a whole square. So in region 1, the circle is above the parabola. So we can say that this function is greater than this function. It means that root over 16a square minus x minus 4a whole square, that is obviously greater than mm, y is equal to, so if we solve it, we will get plus minus 2 root ax. So that is greater than 2 root ax. Or we can say that if we simplify this, we will get uh, root over 8ax minus x square. That will be obviously greater than 2 root ax in region 1. And in region 2, we can see in region 2, the parabolic part is lying above the circular part, means the parabola is above the circle. Parabola is above the circle. So in this region, it means that the function of this function is above this function. It means that root over means 2 root ax, that is greater than root over 8ax minus x square. Okay. So area of this of the region 1, that will be obviously integral. It is going from 0 to 4a. So it will be 0 to 4a, which is root over 8ax minus x square minus 2 root ax dx. Then plus this will be 4a to 8a. This will be 2 root ax minus root 8ax minus x square into dx. So therefore the area of the region 1, that will be equal to 0 to 4a root over 8 ax minus x square minus 2 root ax dx, or we can write this as 0 to 4a. This will be equal to, obviously you can write as 16a square minus x minus 4a whole square. So then minus, we can write 0 to 4a 2 root ax dx. So this will be, so here if it, so this is dx. So here we can, here if you take x minus 4a equal to t, then dx will be equal to dt. And when x is going from 0 to 4a, so t is going from minus 4a to 0, since x is going from 0 to 4a. So t will go from minus 4a to 0. So this will be minus 4a to 0 root over 16a square minus t square into dt. Then minus, this will be 2 root a is a constant, so it will come outside. So root x dx, that is going from 0 to 4a. So this will be equal to so 16. So we know that square root of a square minus x square dx, so that is equal to x by 2 into square root of x square minus x square, then plus a square by 2 sine inverse x by a. So this we have to use here. So this will be equal to t by 2 into square root of 16a square minus t square, then plus 16a square by 2 sine inverse x, sine inverse t by a is 4a, and that is going from minus 4a to 0. Then minus 2 root a, this will be x power half plus 1, means 3 by 2 by 3 by 2, and that is going from 0 to 4a. So this will be equal to, so if you put 0, this will be 0 only, and this will be 0 also. Then so 0 minus, this will be 4a, if you put, then that will be 0 also. Then minus 4a, so this will be minus 16a square by 2 sine inverse 4a by 4a. Since sine inverse minus x is minus sine x, okay, so this will become then minus, this is 4 root a by 3, then this will be 4a whole power 3 by 2, then minus 0 power 3 by 2. So this will be equal to plus this will be 8a square into sine inverse 1, that is pi by 2, then minus 4 root a by 3 into, this is 4 root over 4, that is 2, so 2 cube, that is 8, and a power 3 root 2, that is a root a I can write. So this will be equal to 2 4 is 8, so 4 pi a square, then minus, this is 4 is 32 by 3 a square units, obviously. And then we need to find the area of the region 2. So therefore the area of the region 2, that will be equal to 4a to 8a 2 root ax minus the square root of 8ax minus 16, sorry, this is a square x square minus x square into dx, yeah, into dx. So this we can write it as 2 root a integral root x dx, that is going from 4a to 8a, then minus, this will be integral 4a to 8a square root of 8ax minus x square into dx. So this will be equal to 2 root a, then this will be x power 3 by 2 by 3 by 2, and it will go from 4a to 8a minus this will be, we can write this as integral, this is 16a square minus x minus 4a whole square, and this is 4a and 8a dx. Then so this will be equal to so this will be 4 root a by 3. This will be 8a whole power 3 by 2. Then minus 4a whole power 3 by 2. Then minus, this is obviously, we can write it as root over 16a square minus t square into dt. Since why, if you take x minus 4a equal to t, then dx will be equal to dt. And x is going from 4a to 8a. So t will go from 0 to 4a. So this will be 0 to 4a. So this will be equal to 4 root a by 3. And this will be equal to root over 8, that is 2 root 2. So 2 root 2 whole cube, that is 8 into root 8. So that is 8 into 2 root 2 into a root a. Then minus, this is square root of 4 is 2. So 2 cube, that is 8. 8 into a root a. Then minus, this will be t by 2 into square root of 16a square minus t square. Then plus a square by 2 sine inverse t by a. And that will go from 0 to 4a. So this will be equal to 4 root a by 3. And from here we can take 8 into a root a as common. So this will be equal to 2 root 2 minus 1. Then minus, then if you put 4a here, this will become 0 only. And this is 4a obviously. Okay. So this will become 8a square into sine inverse 1. Then minus, if we put 0 here, this will become 0 only. So this will be equal to 4 is a 32. 32a square by 3 into 2 root 2 minus 1. Then minus 8a square into, this is sine inverse 1 is pi by 2. So 2 4 is 8. So this much square units. Then we need to add the area of the region 1 and the region 2. Then we will get the area of this shaded part. So therefore, the required area of the shaded region, that will be equal to, this is 4 pi a square, 4 pi a square minus 32 by 3 a square. Then plus, this will be equal to 32 a square by 3 into 2 root 2 minus 1. Then minus, this is 4 pi a square. So this much square units obviously. So this will be equal to 4 pi a square. 4 pi a square will cancel. So this will be minus 32 a square by 3, and plus this will be 32 into 2 is 64 root 2 a square by 3 minus 32 a square by 3. So this will be equal to, so 64 root 2 a square by 3. Then minus this will be 2 into this. So 32 into 2 is 64 by 3 a square. So the answer is 64 a square by 3 into root 2 minus 1. So this much square units. So this is the final answer for the area of this shaded region. Thank you.